In early 2025, a fintech company deployed an autonomous agent to reconcile transactions. It seemed functional until it hit a logic error and entered a runaway loop. The system executed the same failing process over and over for 11 days before anyone noticed. Of AI agent initiatives fail to transition from pilot to production. These initiatives die because we treat large language models like magic wands, expecting them to behave like standard software. But a raw LLM is probabilistic. It is an inherently unpredictable component that can spiral into infinite regressions if it isn't properly contained. Foundational intelligence is a secondary concern. If you lack the systems engineering to prevent these runaway loops, the smartest model in the world will still find a way to burn through your budget. Most developers start with single-shot prompts, one massive instruction. But Google DeepMind found that in unstructured setups, errors cascade. When agents pass data without a plan, they amplify errors by over 17 times. To stop this amplification, the industry is moving toward the agent harness. This is a layered reliability framework that wraps around the non-deterministic model, creating a secure environment for the AI to operate. This shifts the developer's role. It's no longer about finding the perfect magic word prompt. It's about building the infrastructure for continuous lifecycle management. The first layer is intent routing. Think of it as air traffic control. Sending a high-level coding request to a basic customer service agent triggers a misclassification cascade. You waste tokens and trigger useless tool calls for a problem that agent was never designed to solve. To solve this, platforms like Salesforce's Agentforce use a hybrid approach. They use zero-cost keyword matching for simple requests and only escalate to expensive LLM routing when a query is truly ambiguous. This precision allowed them to scale to over 18,000 autonomous B2B deals. Once routed, tasks need a supervisor-worker hierarchy. A centralized tech lead agent dictates specific tasks to subordinates. Klarna used this structure to handle 2.3 million monthly chats, doing the work of 700 humans and reducing resolution times by 80%. Strict hierarchy eliminates the noise of unstructured collaboration. It ensures specialized cognitive labor actually translates into measurable enterprise efficiency. To handle uncertainty, agents use the react loop. Think, act, observe. Like a chef tasting soup, the agent continuously assesses, uses tools, and adjusts. This loop powers Permeplet agent, generating 2.5 million lines of code daily with a 92% success rate. But if a project has 10 or 20 steps, a single loop is too slow. You need parallel delegation. The planner decomposes the goal into independent subtasks that are executed by specialized agents as tightly stacked concurrent taskbars. Uber uses this to automate design specifications. By letting specialized agents pull data from Figma in parallel, they've turned weeks of manual documentation into minutes of automated execution. Separating upfront planning from parallel execution is the only way to scale these operations without hitting sequential bottlenecks. Prompts are probabilistic, which makes them a security hazard. You can't just ask an agent not to reveal sensitive data. You need deterministic safety layers called functional middlewares. These hard-coded wrappers intercept every tool call to block prompt injections and scrub output data. Security research maps the blast radius of unguarded agents. A single compromised instruction could authorize millions of dollars in fraudulent orders in seconds. Because AI operates at machine speed, it can drain a budget before a human auditor even receives an alert. This is why production agents require circuit breakers. Using the STEP protocol, set caps, trace, ensure state changes, and probe exit conditions, the harness monitors for logic plateaus. If an agent fails to improve its score after 3 rounds, the breaker severs the connection and forces a graceful fallback. Without these deterministic guards to halt recursive loops, an autonomous system has the potential to autonomously bankrupt its own organization. Long-running agents eventually suffer from context rot. As they read endless logs and conversation histories, their limited memory fills up with irrelevant data. They can ingest memory, but they can't selectively delete it, a problem developers call LLM malloc-free. The solution is the Ralph Wiggum loop. Named after the persistently naive Simpsons character, this architecture resolves context rot by terminating the agent and wiping its memory after every action. Instead of a long history, a completely fresh agent to spawn for the next step. It reloads only 2 things, the latest specification and the current codebase. By forcing progress to live in version control rather than the LLM's finite memory window, engineering teams ensure that the agent remains sharp and persistent over months of work. To move past the pilot phase, we have to move past single-shot thinking, dynamic routing to triage tasks, hierarchical planning to coordinate labor, and parallel delegation to scale. This master blueprint is the agent harness, wrapping that cognitive engine in deterministic middlewares, circuit breakers, and observability tools like Arise Phoenix to trace every decision. A moment of wait. In an enterprise environment, an AI agent is only as capable as the guardrails surrounding it. A stronger harness is vastly superior to a smarter model.